the plan is to go through FRQ real quick. I like the 2016. I don't know why. 2016 was a good year. All right. If I got any wrong questions or like wrong answers, I'll just put it down in the description down below. Let's go. So question 1. Water is pumped in the tank at this rate. Okay, let's just estimate R prime of 2. Okay, R prime of 2 is basically, I'll just basically do this. Okay, I won't actually solve it because I don't want to use my calculator. But yeah, let's go. So basically, this is R, right? You want to know the rate of change of R at 2. You are given this interval values on this interval. So it's basically R3 minus R1, and then you'll get the average rate of change, and then you divide it by 2. Since 3 minus 1 is 2, and then yeah, you'll get it. All right, B, that's A. So use Riemann sum with the 4 subintervals indicated by estimate the total number removed by from the tank. Okay, left Riemann sum. Basically, you want to start with here. So so this is y1. You want to say like 1340 times 1, since this is one interval, and then plus let's see, 1190 times 2. You see, because this from here is 2 intervals, this from here is 1. You want to only calculate the left, right? Okay, and then and then plus 950 times 3, and then plus 740 times 2. All right, that's B. C, yeah, you want to calculate this by yourself. I'm not going to calculate it here. All right. C, use your answer from part B to estimate total amount of water in the tank. Oh, actually, wait, hold on. Is this hold on, estimate the total amount of water removed from the tank. I mean, this is only asking for the total amount of removed, so this is right because R represents remove, and the water coming in is W. You want to remember to take that into account for C. However, you'll also want to give a reason if it is a overestimate or underestimate. So I would say this is a overestimate because this function looks like it is decreasing. Let's see. Yeah, it's decreasing, but if you're estimating according to the left, you're always like having an overestimate, because yeah, let's just say it is a overestimate because this is a decreasing function. Yeah, and then maybe you can explain more than that, but I think this will just give you the point because it's decreasing. All right, C. Yeah, as I said, so perhaps since you have an estimate already, what I will do is since you have this much water leaving, and you're given when t equals 0, there's 50,000 liters. It will be 50,000 minus this whole thing that you have calculated. Let's just say it's B because I calculated from part B, and then you want to add water pumped into the thing from 0 to 8 of WT, and you can calculate that for yourself. Why? Because WT is something that is the water that has entered the tank, so that gives you the total water in the tank. Since there are water still coming in, you want to take the integral of the total water that has came in, so the total water in the tank at the end of 8 hours. All right, so D from 0 to 8 there at time at the same rate removed from the tank. So yeah, if you do enough FRQs, you'll just know every time there will be something like this. So is pumped in as the rate removed from the tank. That basically means when RT equals WT. Pumped, since this is pumped in the tank, same rate at the removed from the tank. Let's see how if these will intersect. If these intersect, yes. If these don't, it's no. Alright, that easy. Okay, next one. So this is not that hard. This one is not that hard, at least as of right now. Let's see. Let's check actually. same rate. Yeah. Okay. Oh, actually, it might be a bit tough because like because because this RT is just estimate. Um, let's see. Okay, we can do this. So for sure, maybe we have to use MVT because there has to be a point at which our like there has to be a point where wait, this is the rate of change. Oh my god. Hold on. Let's see. Okay, this is not that easy actually. Sorry. Um, wait. Let me clear my mind right now. So since the there are like this much water, and then okay. So if you have this much water, you wanna calculate B divided by 8 and see if there's any WT that intersects with this. Since yeah, this is the average rate of change. This is the average rate of change calculated from part B. And yeah, that would be the best way that I can solve this. Okay, I'll check my answer later and see if this works. All right. Okay, so if this works, then yes. If it doesn't, then no. Yeah, that will be my answer. Okay, so for t larger than 0, particle moves on x-axis. Velocity is this. It's speeding up or slowing down. So to know if it is speeding up or slowing down, you want to see if the second derivative has the same direction as the velocity. So first you want to take the derivative of velocity. So vt equals 2 cosine t squared over 2 times 2t, and at t equals 4, this thing equals to 8 cosine. Why am I messing up with cosine? Oh my gosh. Times 8. Why do I just have to use my calculator? Oh my gosh. This is negative. Alright, if this is a negative number, this is negative 2.328, and it's speeding, if it is speeding up or slowing down. Oh, 1 plus. By the way, I don't hate making these videos. It's just I don't like to use the calculator. It's very like, I just don't want to spend as much time. So I think it's speeding down because v equals v4 equals positive 2.979. So since they have different directions, it has to be slowing down. It makes sense because when your velocity is like positive, that means you're still like going this way, but you have a negative acceleration, which means you're slowing down. I don't know how to explain that. It's just how it works. All right, so B. Find all times t when the particle changes direction. When it changes direction is basically when vt equals 0. Just plug it into the graph and then see like 0 when it's 0. Like for instance, if you have this, these are the points where it changes direction. All right. The reason is that the derivative changes from negative. Let's see if I can draw this, negative, positive, and stuff. All right. Yeah. We know the derivative, like the derivative of the position changes direction, changes from positive to negative. You know that this point just has to be. Wait, let me just explain the whole thing again. So you have a graph representing the this is the velocity, right? When velocity equals 0, it means it's changing from positive to negative. And what does positive velocity mean? It means you are going this way. What does negative velocity mean? It means you are going this way. That's it. So okay, see, find the position of the particle at t equals 0. So what? Take the antiderivative, I think. If you take the antiderivative, you get x plus -2 cosine, since like the derivative of cosine is negative sine. Alright, and then you get this thing doesn't change forever, but this thing changes. So I think it's this. Let's check. If I take the derivative of this thing, wait, okay, it's this. If I take the derivative of this thing, oh, don't forget the c, dude. I'll get 2. I'll get. Wait a minute. I'll get 2 sine t squared 2 plus 1. Okay. Alright, that makes sense. Okay, so it's this thing over here. It's at 2 when t equals 4. So, oh, this is not x, this is t. So it's 4 minus 1 over 4 cosine 16 divided by 2 plus c equals 2, since this is like xt. And then just find solve for c. Alright, solve for c. C equals something, and then you want to just express everything in term when at t equals 0. This is how you solve it, and solve it yourself. D, find the total distance the particle travels from time t equals 0 to time t equals 3. Total distance, oh, as I have said, vt, this is the total distance formula. Alright, remember this and just plug it in. Yeah, you don't even have to plug distance in, you just have to plug in the velocity. I think the velocity is a better way to approach this, because you don't know when your position might be negative. That would be really tough. Okay, so okay, 3, I might post this in 2 different videos. Alright, okay, 3, does g have a relative minimum, relative maximum, or neither at x equals 10? I think when it's at 10, it equals 0. It equals how it started. So I think neither, because equals x equals 2. Okay. For me, I would just say from here to here it equals 0. At here it equals 0. That's it. So I mean, this equals this of the function, so it doesn't represent anything. Alright, B. Wait, is this a good answer? Let me see. Let's do the candidate test. If you take the derivative of gx is basically, gx is basically fx. Yeah, remember, if you just have it like this, it's still the derivative of gx is just fx. It's the thing inside of it. So fx at 10, f10 equals 0. Oh, f10 equals 0. I guess it does have to be like some kind of like it's a candidate, that's why. So it's changing from something. So when it's here, it's negative, right? When it's here, it's also negative. I think it's just a relative. I think neither. Then it's neither, because it's just changing from negative to negative. So yeah, that's why, because the g prime stays the same, so it's neither. Okay, does graph of g have a point of inflection at point x equals 4? Point of inflection means the concavity changes. So take the second derivative of this thing, you'll get like 2. Second derivative is positive. Oh, and then the second derivative from this place is negative. So yeah, it does have a yes. That's why, because g double prime of x changes from positive 2 to negative 2. Alright, C. Find the absolute minimum value and the absolute maximum value of g on the interval -4 thing. I was super confused about this because like I didn't know if this is negative. I feel like this is still negative, honestly, if I were to say. So this is -2. No, 2 times 4 divided by 2 is 4. Alright, -4. And 12, I guess the absolute maximum might be this, like to 6, and then absolute minimum might be, yeah, it might be just -4, just in case. So yeah, so either way it's -4, right? Because this cancels out, leaves out this chunk, and then this is the only positive value that I can get. So yeah, so it's 4, -4, and justify. Okay, D, from -4 to 12. Find all intervals for which gx is smaller than 0. Gx is smaller than 0 when, oh, hold on a minute. Yeah, this is -4 too. So it's -8. So it should be -8, sorry. Yeah, it should be -8. Wait, hold on. So it's 4, -8, because this chunk over here is just a negative number. This is positive, so don't think about that. Alright, so -4, because like if you calculate it from starting from 2, counting backwards, this will give you a positive value. This area will give you a positive value instead. Okay, when gx is smaller than 0, yeah, as I have said, this interval it's always 0, and then this interval is 0. That's it. Okay, so for differential equation, I like this. Okay, so slope field, yeah, just plug it in, I guess. When it's 0, it's -1, 0, it's just 0, so 0. And then when it's 2, it's 1, and it's still 0. And then when it's 1, you get 1, so it's this. Yeah, because 2 minus 1 is 0, is 1, 1 over 1 is 1. And then when you get 2 is 4 over 1, you get this. And then 4 over -1, you get this, since x is 0. And then 1 over -1 is -1. Yeah. Alright, so B, particular solution with a condition. Alright, this is very easy. Every time when you do this, just do this. dy equals, don't even think about it. You just have to, like, you know, switch the sides of these two things, because you can always, like, you know, switch around these. So yeah, remember how to do that, and then take the integral of both sides. That's what you have to do. And then I'll use so this over here is just this. Don't mess it up with ln of x. And this over here, I think I can use substitution. So if I were to prove my steps, this is, yeah, and I get ln of x minus 1, since, yeah, I'm using this ln method. And then, yeah, plus c, don't forget, because you are taking the indefinite integral. And then for this, I would say, yeah, I get -y, right? If I did math right, yeah, I did. Okay, so when 3, this is -1 over 3 equals ln of 1 plus c. ln of 1 is 0, so c equals -1 over 3, and hence Oh, this is not the right way. Sorry. This is really hard. I don't recommend this way. The easier way is you switch around first. So if you switch it around, you want to do this equals negative 1 over ln of x minus 1 plus c. Yep. Yeah, I think I did it right. Yeah. Write the equation tangent to the graph of y equals fx at x equals 2. Let's see, dy dx. Hold on. Wait, what? Let fx. Okay, I've been doing this too much. What am I doing? Alright, anyway, that's C. B, the tangent line, you just have to know that, like, the equation for the tangent line, you want to take you just want to use the derivative. The derivative at x equals 2, you want to plug that in. It's basically 9 over 1, which is 9. And then when you get 9, you want to plug that back in. Approximate f of 2.1. Let's see. So, let's see, the line representation is 9x plus b equals 3. So x in this case is 2 if you plug that back in. So it'll be 18 plus b equals 3. B equals negative 15. Alright, so when b equals negative 15, y equals 9x minus 15. And then just plug that back in. And then for this one over here, let's keep on solving it, bro. Okay. So when it's 3, when this is 3, you get 0 plus c over 1. Oh my gosh, what? Alright. C still equals negative 1 over 3. Yeah, so ln of 1 is 0, right? Yeah, it is. So y equals negative 1 over ln x minus 1 plus 1 over and the minus 1 over 3. Alright, that's it. Okay, 5. Oh, this looks hard, but it's really easy. Find the average value of radius of the funnel. Since it's given the term the rate, I will say the average value of the funnel, we can calculate it by the average distance formula. The average distance formula is 1b minus a to b of like the velocity, I would say. Yeah, I think oh no, it's this is the average distance. I mean, no, average position, average speed. Wait a minute, this is getting a bit confusing, but let's just say average value is when it's at 0. So let's say the biggest r biggest, let's make it less confusing, minus r smallest, and then divided by 10. So when r is at the biggest, it's it's when h equals 10 minus when h equals 10 and when h equals 0. Plug that back in, calculate the average value. I think that gets you the right answer. Let's check. Just make sure. 1 divided by 20 times 3 plus 100. I feel like no. It has to be the integral. Sorry, it has to be the integral because you're calculating every height and then dividing it by the total range. So I'll say first find this is the, let's say this is the position. All right, it's asking for average position. The integral from 0 to 10 of r dh. I think so. Yeah, this makes sense because you're calculating every possible h. Let's just plug it back in. My brain is not working right now. 0 to 10. Yeah, this really simulates like a actual situation on your exam because you've been doing a lot of things and you can't really think of anything right now. Okay. So let's see. So this thing gives me 18.166. This thing gives me 18.167. And then, oh, you can't actually use it. You cannot actually use a calculator. Sorry, bro. Okay. For this session, you cannot use a calculator. So I might just do this. Let's take the, I think we should take the derivative first of all. Take the derivative is this, and then oh yeah, the integral of the derivative is the total value, and if you divide it by 10 is the average value. All right, yeah, so if you take the derivative of this thing, dh, you get fundamental theorem of calculus. This thing equals, this whole thing equals, yeah, you don't have to actually calculate the derivative. 3 plus 100 minus 1, 3. That's it. Yeah, that's it. That's all you have to do. And then you want to divide this chunk over here by, it's basically 5. Yeah, because like you get rid of these. 5 divided by 10, which is 0.5. This is the average value of the funnel inches. Sorry. Yeah, sorry for taking that long, but yeah, brain wasn't working. And if you want to check, let's see, when it's 0, it's only 3/20, which is very, very small. So yeah, that makes sense. Okay, B, find the volume of the funnel. Let's see. So I think apparently this is dy-ing. I think this is dy-ing because you're going from here to here, and then the h is the value that is changing. So it's changing from, this is 0 and this is 10. All right, so let's see if we can represent this in terms of that. So the volume of the funnel is pi r squared and then you want to multiply by a little piece of h, so you get you want to do this, and then how do you represent h actually? It's just dx. Yeah, so it's this. If this makes sense. Oh my gosh, I've been thinking too much. So yeah, this is how you represent everything, and this is the basis of calculus, and this is why calculus is useful, since you can like use dy to calculate everything. Okay, and then you want to represent r in terms of h. and then the volume will be you don't even have to think about the graph because yeah, because it's just a graph. It's just like a picture. It's a diagram of a volume. And yeah, this is not dy, this is dh. This is it, 0 to 10. And then to get the value, you wanna take this out and then find the antiderivative. You can find the antiderivative of this whole thing right here. You can do that by finding the antiderivative, I guess. Let's see how can you do it. I would use so if this were to be my original thing, I would need to do this. This is my antiderivative. Okay, if I take the derivative of this thing over here, I will get first it's 3 plus h squared over 2. I'll multiply it by 2h, which is the derivative of the inside if you use the chain rule. Then you get this. Alright, that's proved. And then you're gonna multiply it by pi, and you'll plug the 10 in. You get 800h. 800h. 3 plus 2, and then this one cubed from 10 to 0. That's it. Okay, I hope I got it right. And that'll be the volume, and then you want to simplify it. Let's see. Oh my gosh, I spent too much time on this, but yeah, let's see. This is the last few questions. And C, the funnel contains liquid that is draining on the bottom of the room. Radius, it's decreasing at a rate of 1/5 inch per second. At this instance, what is the rate of change of the height of the liquid with respect to time? Okay. So it's asking the radius is decreasing at it. It's basically a related rates question. So let's see. Let's actually move all of these up there. Move it like up here, I guess. Okay. So for this question, dr dt equals 1/5, and then take the derivative of this big chunk over here. You got 2h over 20, 3 plus h squared. Yeah, I don't know what is this. Hold on, what actually is the derivative of this thing over here? You just get this. This is the derivative. What? The derivative of this whole thing over here is 3 over 20 plus h squared over 20, which is 2h over 20, which is h over 10. Okay. Wait, why does that make sense? Rate of change of the height. Okay. dH dt. Oh yeah, implicit information. Okay, that's how you solve this. Okay, So it's basically 2 over h equals dh dt, and when h equals 3, it's 2 over 3 equals dh dt. So yeah, this is how you get the rate. Since you got the rate of change of the radius, and then you can relate the rate of change of the radius according to this function right here, and then h over 10. Yeah, okay, that makes sense. dh dt. Okay, so this is my answer over here, 2 over 3. Hope I got it right. Okay, last question. Let's finish this real quick. Graph of k. So find the derivative. If you want to find the derivative of kx, you get f prime gx, chain rule, g prime of x, and then when it's at 3, so this is a you want f prime of g3 times g prime of 3. What is this? g3 6 times 2. So it's f prime of 6 times 2. What is f prime of 6? F prime of 6 is 5. Okay, so it's 5 times 2 equals 10. So yeah, this is a, okay, B. Ooh, okay. So since you know f is just 6, that's why you have to use L'Hopital's. I think, yeah, you want to use L'Hopital's. Yeah, because according to L'Hopital, wait, actually no, you cannot. That's only for limits, alright? It's not L'Hopital's. So h prime of x, this is the quotient rule. G prime of x, fx. Yeah, according to the quotient rule, it's basically this minus the product of these. You just want to remember this. This is very important. This is basically fx squared, since it's on the bottom. Alright, so when it's 1, all of these, bro, all of these, man. So it will be 8 times negative 6 minus 2 times 3 over 36. Alright, that's it. Yeah, just calculate that. And A, finally, C. So for C, 1 to 3, okay, it will be f prime, oh shoot, okay, let's see. So if I were to do this, f prime of 2x's derivative would be this 2 will come out because of chain rule, so this will be the original form. Okay, you want to evaluate this from 3 to 1. I think this is right. Yeah, this is pretty much right. Yep. Okay, f prime of 2x, so it'll be 6 to 2. Checkmate. F prime of 6 equals 5 minus 1 over 2. 5 minus 2, which is negative 2, which is plus 2. Alright. 7 over 2, 3.5. Okay, this is my answer for C, and I hope I got it right. Pretty tough packet, especially at the very last part, at the very last bit, but I got through it in like 39 minutes. Oh my gosh, I gotta improve this. I don't know how I can post this video, but I might split it into 2 parts. But yeah, this is it. I'll see you.